All right, it's 7 o'clock, so I'm going to start my talk. I'm going to get mine out of the way before Brandon does his, because his is really cool. So I'll just get started. So Network Analysis Home Lab, I've been diving deep into this lately. But before I start, since I know there's some new faces here, my name is Collin. I guess what qualifies me, hello, what qualifies me to talk about network analysis? I've been a network engineer for a while. I just moved into a SOC position, but just been huge into network engineering, network analysis, stuff like that for a while. So why would you want to analyze your network traffic? This can be, so this is related to home lab, but this will translate directly into an enterprise. It's how you detect on IDS behaviors, alert for malicious behavior on the network. All or most malware has to traverse the network, so it's going to be one of the best ways to discover it. Abnormal traffic patterns. So for home lab specifically, tuning your pie hole for enterprise DNS. Learn what common exploits look like at a network level. I think that's super important when you're learning how to pen test or trying to understand how to defend yourself from red teamers. Create PCAPs of interesting data, send it to peers, share it out to the community. There's tons of open source or like community-driven projects and companies that need those PCAPs, so it's always good data to collect from every network. Investigate traffic behaviors for IoT devices. You'll see in my slides here that tons of IoT devices on my network that are generating not important data that you can start blocking. And then investigate untrusted applications. I used a game overlay for an example, but applications you don't necessarily trust might be talking out to advertisement, services, who knows what. It's just a good chance to discover that. Things to get you started for super cheap. This is like college level budget, right? So if you're in college and you're doing IT, I'm assuming you have a computer. You get started with Wireshark TCP dump. I discovered Procmon like literally last week, kind of embarrassingly, but it's a super good tool. Untrusted applications are, this is all free stuff, right? So running untrusted applications, VMware Workstation, VirtualBox, and then a Pi hole. I know Raspberry Pis are more expensive now, but you can also virtualize that. So the first absolute free thing that you have to know to get into network analysis is Wireshark or TCP dump. If you don't know Wireshark, it's just a packet capture analysis tool. It's showing you the TCP UDP layer, the like network protocol layers of everything. There's a ton to learn there. I might give a talk someday just on Wireshark, but that's kind of the first thing it takes. Procmon. Procmon is an application analysis tool. I guess I don't know exactly how to describe it, but you can run it, start filtering out certain applications you want to see. You can filter out registry edits, file edits, network traffic. Network traffic is what I was specifically interested in. That's not in this screenshot, but I did discover some interesting stuff through it. And then Pi-hole. If you're in like IT and you don't use Pi-hole, like guys, it's so cool. It's just home DNS. It does ad block. It's a network level ad blocker. You can add your own ad list. You can add your own blocks, whitelists, DNS. It's the sky's the limit with this. It's such a great tool. You should all be using it. But specifically for the reasons here is there's a lot of logs you get out of DNS that are super important to be analyzing your traffic. This is just an example. This is the logs. Obviously, there's like an Amazon Alexa somewhere on my network. So what can you accomplish with a super cheap, limited, like college budget lab? PCAP exploits inside of Kali. Review them afterwards. Run some Metasploits against a Vuln Hub box. Capture that traffic inside of Kali or inside the box you're trying to hit. Look at it. That's all you got to do. It's interesting. You'll learn a lot about what these exploits are trying to do. Sometimes it's interesting enough that services might want that PCAP. getting a little bit deeper into it, you can start doing some Wireshark TLS decryption locally. It's not super in depth, but it's good enough. You'll start opening up TLS. You'll start understanding how the handshakes happen, and you'll start understanding, like HTTP 2 and traffic like that. Block all your unwanted spyware, adware from apps, like I went back to earlier. I'll cover some of that with the game overlay, but so this is where my talk was leading to. The big lab is more like run everything that I mentioned prior, but it requires a little bit more hardware at this point. It can be done cheaper and easier, but you'll run into a lot of weird issues. OpenSense Firewall is the one I recommend. I know pfSense is kind of the big known one. OpenSense is like actually completely open source, that you don't have to pay for anything. Having some type of hypervisor, you can run your firewall and everything on your hypervisor. I chose not to, but you need the hypervisor for an AD environment, for Kali, for whatever. And then I recommend a bare metal Security Onion machine. It's going to take a lot of troubleshooting out of the equation. I tried virtualizing Security Onion for a long time. It wasn't the way to go. I just ran into a lot of issues that I didn't really understand were related to virtualization at the time. Physical network tap. This one doesn't technically have to be done. You can do some like span traffic on your switches. I recommend a tap. It's super easy to move around. It just works. There's absolutely zero config. You just plug it in and it's mirroring your traffic. And then normal home network traffic. Having a family that you live with helps. You can get a lot more interesting data. So starting with OpenSense, just basic open source firewall. There's absolutely tons of plugins, more and more every day, that gives really good useful logs. You can export those logs over syslog to things like Splunk, Elastic. I run it as my border, IDS, IPS, running similar rules as Security Onion is, but it's kind of on its own on the border. You can add custom block lists. It's a firewall. It doesn't take much to run it either. You can use an old laptop. I guess the minimum is you need 2 NICs, right? So hypervisors, virtual environments. This is one I've been toying with the longest. I've tested lots of different products. All of these products are great, but ultimately I landed on ESXi. It's stable. It has a free version that's useful, but 99% of the reason I chose it is it has the remote console. So I launched my Kali box from a machine that's sitting in my basement up to my desktop, and it runs natively like it's running on my desktop. That was the biggest deal for me. Security Onion. This is the blue team Kali. This is the coolest tool you'll use as a blue teamer, in my opinion. It does log collecting through Elastic. It does IDS through Zeek. You can set up endpoint monitoring with things like Waza, custom alerting. You can use it as a home enterprise SIM, home enterprise SIM endpoint. It does it all. Other useful containerized tools: CyberChef, MITRE Navigator, Detection Playbook. It has everything you need to learn how to run a SOC at home. I have some screenshots of some alerts, mostly collecting IDS alerts at this time. So admittedly, it crashed 1 week into me trying to collect a lot of this data. I chose a bad hard drive and it died, so I don't have a lot of great data in these screenshots, but just ET, IDS logs. I visit Discord a lot, obviously. Here's a little bit more of Security Onion's. This is the hunting service. I'm just looking for SSL server names. My nephew obviously really likes Roblox. That's always one of our most visited. And then dashboards built right in. This is 30% of what Security Onion has to offer, on not including all the agents and tools you get included that I haven't yet tuned, but just powerful tool. And then, of course, I think the coolest tool, p-capping. I think the things you're going to get most out of p-capping is running your tap between a box you're trying to exploit and breaking down that exploit through this PCAP. You're getting like raw network traffic in between. You're not getting it from one box. And then I thought this was funny, but Security Onion saves its PCAPs as Sensoroni. I just always got a kick out of that. So physical network taps. There's tons of options on the market. I didn't list a bunch of them. I just have pictures of the one I have. But they're all going to be good, assuming you get like a 1 gig off the used market. I have a Gigamon that I got for free from a friend. 2 ports in, 2 ports out. This explains it a little bit more. Please don't mind my cable management, but it's a lab. In this scenario, it's sitting between my core infrastructure to my firewall, mirroring all that traffic down to Security Onion, which I think, yep, here I have the picture right here. Those are both of the mirrored ports on the right. That's my management port on the left. So going back to this real quick, you can move that tap anywhere in your network you want. You're going to be capturing that into your Security Onion. You can have multiple taps, and you can send multiple taps to your Security Onion. Where to place the tap? Anywhere you want. Where do you want the interesting traffic? I started right before the firewall to start gathering like outbound traffic data. I currently have it on the outside of the firewall, planning on hosting a website, seeing what kind of pokes at it, seeing what alerts I get out of that, and then ultimately put it between a box that I plan on exploiting and gathering a ton of data from that. I mean, you can put the tap can go anywhere at any point. So natural and artificial traffic. The challenge I have with any home lab is trying not to piss off my significant other. This started with network engineering and went into security, but you can't. It's not going to happen. But it's great, realistic user experience. You take the network down, they're going to get angry. The best place to learn is in a lab. Don't do it in an enterprise environment. So natural traffic, work devices, school devices, desktops, laptops, IoT, phones. I think the most interesting traffic I've found has been IoT and phones. Apps like to reach out to ridiculous things, and IoT devices like to reach out to ridiculous things. Artificial traffic, sandbox labs. This is not something I've admittedly gotten into yet. I plan on doing it. I want to see C2 malware reaching out. I want to see ransomware reaching out. I want to see this stuff live. I think it's best to do this in an isolated environment. So that's kind of what's holding me back at this point. The big one I have played around with is Pentest Labs, doing boxes with VulnHub and tapping in between that. Test OWASP top 10 attacks, RC, Metasploit, capture that. If you don't see it get picked up in a like an IDS rule set, it could be extra interesting. Network scans, I mean, you should normally see these things picked up, but Nmap, Burp Suite, Responder, if you don't see those get picked up, could be extra interesting. But these are all learning experiences. Seeing the alerts trigger after you use them, seeing why. So putting it all to use. Okay, sorry, I thought I skipped one. So I started looking for excessive traffic. So on the left here, I had block domains. I think this is coming out of Pi-hole on the left. So the top two were not, actually the top three were not originally block domains. That's just where I pulled the screenshot. But these 3 things were like 60% of my network traffic for a while. OpenDNS, obviously, if anyone that works in an enterprise knows anything about Umbrella, it's doing health checks, but it's extremely noisy. So I cut that one short. Things like, NVIDIA, I forget what the GFE stands for, but it's just noisy applications that don't need to be noisy. And then Amazon Alexa, my nephew's Amazon Alexa still works after I blocked this super noisy domain. So I think that's all interesting data. And then you start looking for excessive traffic. I mean, on device-specific stuff, a lot of TikTok on my network, Snapchat, Facebook, Microsoft. You'll see things stand out, and you'll get curious, and you'll kind of start threat hunting at that point. Investigate curious domains. This one, I picked TikTok. My nephew absolutely loves TikTok, clearly. So, I mean, you start digging in, you'll find maybe confusing data. The source IPs here is actually my DNS server, and then my external domain, or my external IP. Don't hack me, please. But this is where multiple sources comes in. So you hop back over to Pi-hole, you figure out what might be talking to it, and you'll figure out, eventually you'll dig into devices. Turns out it was my nephew's phone, like I assumed. And then just keep digging. Keep checking things out, seeing what you can find. I mean, it's cool to figure out what might not, or what shouldn't be on your network that you didn't know was there. Those were all examples, but these were real. These are things that have eaten up tons of traffic in my network that I blocked, and Moby was really interesting to me. It's like a massive Indian advertisement firm that was sending like gigs of data per day out and in. It was the most bizarre thing. So I put a block to those. Some of them, like Game Pass, I don't even pay for Game Pass. I don't know why it was so noisy. So you learn these things and you go forward. And then ultimately packet captures. Sorry, I thought I had another slide there. So packet captures, again, you're gathering. I mean, you can query any source address, destination address. If you're interested in like destination ports and you want to pull all of that into a packet capture, you get this power, and then you can kind of start digging through it and using Wireshark skills that you pick up to find the interesting data that you want. That's why I say Wireshark's kind of the core of all this. Learn Wireshark first. It's absolutely free. Just start playing around with it. There's great resources online for it. What's next? So I plan on doing another talk at some point on these deeper stuff. I didn't get to because my system crashed. But Fleet DM, OS Query, Waza, these are all endpoint monitoring systems you can throw on agent-based for free through Security Onion on your Windows and Linux devices. They'll report back, they'll also throw alerts, and you can create custom alerts and rules and stuff like that. I want to forward all of my Security Onion to like a free Splunk instance, start playing around with Splunk, do a full TLS decryption lab. I think that's kind of like the end goal for me. If you can set up full TLS decryption, you can do a ton of cool stuff with alerting at that point. And then custom alerts and dashboards inside of Security Onion or Splunk if I forward to it. What to do with all this? Like I said, I think the big one is if you're learning pen testing, you're learning SOC, whatever it is you're learning, like it's good to see the actual traffic that is going across your network or that you're creating or looking at. I think you should understand it at a TCP level. You can not only learn how like Log4j, for example, works at the packet level, but you can also maybe find things that aren't alerting and share it with the community. Like there's projects out there that need this information. They need PCAPs. They need, malware, reverse engineering analysis, stuff like that. It's a big community-based project, all of this, and it's a great way to get your name out there. Simulating a SOC, if you've never been in a SOC, I would say this is a good example of how you can kind of start understanding things at a low level, and it's just fun, right? It's super fun to learn and just get into the weeds with this stuff. I guess that's it. Thank you. Oh, yeah, questions? Brandon. My internet, okay, so he asked, did I hook my network tap north or south of my internet egress point and why? And when you say egress point, my firewall? Okay, post-NAT. So initially it was behind my firewall, so pre-NAT. That's where I was getting a lot of that internal IP traffic. And then now currently where it sits is post-NAT. I think the goal is to stand up a web server, something maybe exploitable in a DMZ, and kind of see what traffic might come into it, just from putting it on the internet. Back here? I can't hear you, I'm sorry. So what issues did I have virtualizing Security Onion? Mostly my issues were messing around with the port mirroring to the NIC. Putting an extra NIC in my Blade server and dedicating it, I was just running into mostly hypervisor issues that it's not worth trying to troubleshoot. You're learning a new product. You don't want to troubleshoot and give up on the product because you don't know if it's hard to hunt down what the issue actually is. I think ultimately you probably could do it, but it's easier to start with bare metal because you're limiting the problems you're going to have. Anyone else? All right, thank you.